All right, boys and girls, welcome back to the drive-through. Special shout-out to the Chapter 9 quiz. I think it helped revitalize our class. Okay, so what this is about is conditional probability, okay? So essentially it would be like, all right, I'm going to pick a group of 3, and everyone in the group gets 10 points extra credit, okay? So if I said, what's the probability that I pick a girl? Well, you know, I'd have to figure out how many girls were in here. And then if I selected a girl, now the probability that I pick a girl on the second turn changes, because I have one fewer girl. Does that make sense? Okay, so that's what conditional probability is. So this is going to be a conditional tree diagram. First, let's just read the problem. A bag contains 8 triangles. Always put in triangles in bags. That's what I'm going to do this weekend. Okay? 5 of them are members of the 3, 4, 5, the Michael Jackson family. 2 of them are 30, 60, 90. So we got 5 M's. We have 2 T's. And we got 1 R, right? I guess the other one's just a random triangle. So I just assigned them letters that aren't the same thing. The puppy's always messing with my bags of triangles, dang thing. And 2 of the triangles fall on the floor. What's the probability that both are members of the 3, 4, 5 triangle? So here is your tree diagram as they state. Okay, so the chances of you pulling an M on the first one is 5/8. A T is 1/4, which is 2/8, and an R is 1/8. Okay? We got to go over this notation before the air test. This was a question that tons of kids got wrong on the air test. It was so much easier than this one, but it was because they didn't understand. The kids didn't understand the notation of it. So that's something I got to do for you guys, but this one isn't the notation. Okay, now, M, T, R. If we already selected an M, what's the probability we select an M on our second one? 4 out of 7. Okay? And our T, 2 out of 7. And our R, 1 out of 7. Okay, I'm going to put this down a little lower. M, 5 out of 7. T, 1 out of 7. R, 1 out of 7. Okay? And this one is going to be 5/7, 1/7, and 0. Okay, so we got our tree. What is the probability that both are members of the 3, 4, 5 family? Now, I can tell you, you do not need a tree to do this as long as you know conditional probability, okay? Or as long as you just know the rule of multiplication. What's the probability of selecting a Michael Jackson on the first one? 5/8. What's the probability of selecting one on the second one? 4/7. Assuming we took one on the first one. And then when we multiply fractions, you just multiply across. So I think this answer should be 20 over 56. Have you looked it up? That's fine. We'll see. If it's wrong, then I'll just erase the video. Okay, so that's A. B, what's the probability that at least one of the triangles is a member of a 3, 4, 5 family? This is awesome. Okay? At least is a hard thing to calculate. So what we want to do in part B is we actually want to find the probability that we do not select a Michael Jackson triangle. Okay, you have to hear me out on this. Do you understand that those two things are mutually exclusive? So you either select at least one 3, 4, 5 triangle, or you select no 3, 4, 5 triangles. Do you get that? Well, if I wanted to do at least one, I have to do so many scenarios. I have to do what's the probability that I selected a 3, 4, 5 and then 30, 60, 90. What's the probability that I selected a 3, 4, 5 and then a random? What's the probability I selected a 3, 4, 5 and then a 3, 4, 5? What's the probability I selected a random and a 3, 4, 5? You know what I'm saying? Instead, let's just find the probability that we don't select one. What's the probability that we don't select a 3, 4, 5 on our first poll, that we don't select one? Class? 3 out of 8, right? And if we didn't select one on our first one, what's the probability that we do not select one on our second one? 2 out of 7? And so the answer for this, that's not the answer to the question. The answer for our little thought experiment is 6 out of 56. So in only 6 out of the 56 cases will you not select any 3, 4, 5 triangles. So then what is the answer to our question? So do it. Come on, you can subtract it. So it'll be 50 out of 56, right? So that's the answer to B. Okay. C, what's the probability that one is a member of 3, 4, 5 and the other is a 30, 60, 90? There's two different ways you can achieve this, right? You can do a 3, 4, 5 on your first draw and a 30, 60, 90 on your second draw, or you can do a 30, 60, 90 on your first draw and a 3, 4, 5 on your second draw. So we have to add those together. So we have, what's the probability of a 3, 4, 5 on your first draw? 5/8. And if we got a 3, 4, 5 on our first draw, what's the probability of a 30, 60, 90 on our second draw? 2/7. So that's 10/56. However, we could also have, what's the probability of a 30, 60, 90 on your first draw? 2/8, right? And what's the probability of your 3, 4, 5 on your second draw if we picked a 30, 60, 90 on our first? 5/7. So that's also 10 out of 56. And I add those together and I get 20 out of 56. Ellie, boom!